Welcome back. This is Mr. Erlin working with geometry again, circles. Now we're going to talk about some arcs and angles formed by two secants first, intersecting with a point of intersection outside the circle. This is new for us. As you'll remember, we've just finished working with arcs and angles formed by two chords or two secants that resulted in POIs inside the circle or on the circle, but now we're going to take it to outside. So to begin with, let's do a little proof. Let's derive what we need. I'm going to draw a diagonal connecting these 2 points. And what we're really trying to find here is we want to find a relationship between x, this angle measure, and a, this arc measure, and b, this arc measure. So by drawing in this purple segment, what I've done is I've produced a couple of inscribed angles. The first inscribed angle you can see with a vertex there, and since it intersects arc with the measure of A, we can say that this particular inscribed angle is 1/2 the measure of A by the inscribed angle theorem that we previously proved. Secondly, we can say that this arc, the one marked as B, is intercepted by this inscribed angle. Therefore, we know that this inscribed angle would be 1/2 of B. Okay. Now we're going to look at this angle. Notice that this angle, the purple angle, and this green angle we had previously are supplementary. Therefore, we can say that this angle is 180 minus 1/2 of A. And what we've now produced for ourselves is a triangle. And in this triangle we have 3 angles, and thus we can expect that their sum is 180 degrees. So I'm going to say x plus 180 minus 1/2 A plus 1/2 B should all equal 180 degrees, because the 3 angles in a triangle by the triangle angle sum add to 180 degrees. I'll subtract 180 from both sides, and I'm left with x plus negative 1/2 A plus 1/2 B equals 0. I'm going to bring this over and this over, so I'm going to get x is equal to a positive 1/2 A minus 1/2 B, or x is equal to 1/2 A minus B. This derives for us the relationship that if I want to find an angle measure formed by two secants with a POI outside the circle, I can do it by simply taking the difference, A minus B, of the two arcs and dividing by 2. As an example, if I were to have 120 degrees as this arc and 30 degrees as this arc, I could say that x is equal to 1/2 of 120 minus 30. 1/2 of 90 is 45 degrees. That would be the value of x. And of course, this could be done with a little bit more challenge by putting the variable in a different location. What if I told you this was 20 degrees and this was x and this was 100? Now I'd have to say that 20 is equal to 1/2 of 100 minus x, and I'd solve. Multiply both sides by 2. 40 equals 100 minus x. I'm going to add x and subtract 40 so that I get x is equal to 100 minus 40, or x is equal to 60. And if I think about it, 100 minus 60 leaves 40. Half of that is 20. Now the beauty of this is the way we've proven this will allow us to demonstrate that this is the theorem we can apply to not only two secants with a point of intersection outside, but we could also apply it to two tangents or a secant and a tangent. Notice that, for example, in this scenario I could do the exact same thing, and I can still produce that this arc is 1/2 B, and if this arc is if this arc is B, this inscribed angle is 1/2 B. If this arc is A, this angle is 1/2 A, and this makes 180 minus 1/2 A. We're still looking for x. In other words, I get that same triangle. I could even do it here where we're working with what I call the extreme inscribed angles, because if this line is tangent, this angle is 1/2 A, and this angle is 1/2 B. And this would then be 180 minus 1/2 A, and this would be X, and my relationship would still hold. Therefore, for all these triangles, what I can say is that X is equal to half the difference of the two arcs intersected. As an example, we could then say that if we had, let's pretend those are tangent lines, and this is 250 degrees, and we're looking for X, we'd even be able to take it one step further and say, I don't even need to know this other arc. Because these are tangent, they don't take up any measure of the circle. So if it's 250 degrees from point to point, then the remaining part here would be 360 minus 250, or 110. And I could then say that my angle is going to be 1/2 of the difference between those two, which is 1/2 of 40, which is 70 degrees. Thanks very much. See you next time.